December 19th, 1944. The Ardennes Forest. Oberst Fritz Fullriede, commanding artillery for the Fifth Panzer Army, stood in his command bunker 7 miles behind the German front lines, reviewing reports of the surprise offensive that had begun 3 days earlier. His reinforced concrete position, built according to the latest Wehrmacht engineering standards with 6 feet of overhead protection, was designed to withstand anything the Allies could throw at it. German doctrine held that artillery positions more than 5 miles behind the lines were effectively invulnerable to counter battery fire. The Americans would need to advance their guns to within 3 miles to threaten command bunkers, and by then, German forces would have already detected and destroyed them. At 0900 hours, an American spotter plane appeared over the German positions, circling lazily at 8,000 feet, well beyond the reach of German light anti-aircraft guns. Fullriede barely glanced at it. Observation aircraft were routine, and American artillery, while numerous, lacked the range to threaten his headquarters. The nearest American guns were reported 15 miles to the northwest, positioned near Elsenborn Ridge. Even the American 105mm howitzers, which had proven effective in direct support roles, could barely reach 7 miles. His bunker was safe. 43 minutes later, the earth exploded. The first shell struck 200 meters short, its detonation shaking the forest with a concussion that Fullriede felt in his chest even through 6 feet of concrete. Before he could process what was happening, the second shell landed directly on the bunker's northern wall. The impact was unlike anything he had experienced in 5 years of war. Not the sharp crack of an 88mm or even the heavy thump of a 150mm howitzer, but a seismic detonation that felt like the earth itself had been torn apart. The reinforced concrete that was supposed to withstand any artillery strike cracked and buckled. Dust and debris filled the command post. The third shell followed 18 seconds later, and the fourth and the fifth, each one landing with mathematical precision, walking across the German position in a methodical demolition that left no doubt this was deliberate, aimed fire from a gun that shouldn't exist. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Fullriede scrambled from the collapsing bunker, his staff officers following in panic, emerging into a landscape transformed into hell. The shells kept coming, one every 30 seconds, each 95-pound high-explosive projectile, creating a crater 20 feet across and 8 feet deep. These weren't the familiar 105mm rounds that German troops had learned to endure in slit trenches. These were something far more devastating, fired from a weapon the Germans had never anticipated the Americans would deploy in such numbers or at such ranges. As Fullriede later reported to his superiors, his words captured in Wehrmacht after-action reports now held in the Bundesarchiv Militärarchiv in Freiburg, "They are shooting at us from distances we believed impossible. Our intelligence said the Americans had no guns capable of reaching beyond 12 kilometers. We were catastrophically wrong." The weapon destroying Fullriede's headquarters was the M1 155mm gun, known to American artillerymen as the Long Tom, a piece of artillery that German intelligence had consistently underestimated throughout the war. German planners, studying American weapons development through intelligence reports and captured equipment, had concluded that American artillery, while numerous and well-supplied, lacked the range and hitting power of German heavy guns. The German 170mm Cannoni 18 could fire shells 29 kilometers. The 210mm Mercer 18 could reach 16 kilometers, and the massive 240mm Cannoni Dre could threaten targets 37 kilometers away. These were the weapons that had demolished Polish forts in 1939, reduced French bunkers in 1940, and shattered Soviet defenses in 1941. German doctrine assumed that artillery superiority, like tank superiority, was a German monopoly. The Long Tom shattered that assumption with brutal efficiency. Developed in the late 1930s, as the United States Army recognized the need for heavy, long-range artillery that could match European guns, the M1 was designed to fire a 95-pound shell to a maximum range of 23.7 kilometers, nearly 15 miles. But that was just the beginning of its capabilities. When fitted with special ammunition and supercharges, experimental long-tom batteries achieved ranges exceeding 25 kilometers, 16 miles, putting virtually any target within a division's operational area under threat. German commanders, who positioned their headquarters, supply dumps, and artillery parks based on the assumption that they were safe beyond American artillery range, discovered too late that the Long Tom had rewritten the rules of counter-battery warfare. The statistics of American Long Tom deployment tell a story of industrial and logistical supremacy that German planners never fully grasped. By June 1944, the U.S. Army in Europe fielded 48 separate Long Tom battalions, each equipped with 12 guns, for a total of 576 heavy guns, capable of striking targets the Germans believed were beyond American reach. This was more heavy, long-range artillery than Germany had deployed on the entire Western Front. German intelligence reports, captured after the war, and now available in the National POS archives, repeatedly underestimated American artillery strength, assuming that the logistical challenges of moving and supplying such heavy weapons would limit their deployment. A single Long Tom weighed 30,000 pounds in firing position, required a 10-man crew, consumed ammunition at a rate that strained even American logistics, and needed a prime mover capable of towing 14 tons across European roads and fields. German analysts concluded that the Americans couldn't possibly deploy such weapons in meaningful numbers. They were wrong. American industry produced 950 M1 guns during the war, and American logistics delivered them to Europe, along with the millions of shells they required, the specialized tractors needed to move them, and the trained crews to operate them. The Germans, struggling to produce even a fraction of this number of heavy guns while their factories were pounded by Allied bombers, couldn't comprehend an enemy that treated heavy artillery as a standard-issue weapon rather than a scarce resource to be carefully rationed. The development of the Long Tom had begun in 1938 when the U.S. Army Ordnance Department, studying the artillery lessons of World War I, recognized that American forces lacked a heavy gun capable of counter-battery fire against enemy artillery positioned in depth. The existing 155mm howitzer, the M1917, was an excellent weapon for close support, but lacked the range to threaten enemy rear areas. What the Army needed was a true gun, not a howitzer, with a long barrel and flat trajectory that could deliver precision fire at maximum range. The Ordnance Department turned to the Rock Island Arsenal in Illinois, tasking its engineers with designing a weapon that could outrange anything in the German or Japanese arsenals. The result was a masterpiece of American engineering pragmatism. The M1 featured a 23-foot, 4-inch barrel, giving it a length of 45 calibers, the ratio of barrel length to bore diameter that maximized range and accuracy. The gun was mounted on a split-trail carriage that provided stability during firing while allowing 360-degree traverse when emplaced. The recoil mechanism, using a combination of hydraulic buffers and spring recuperators, absorbed the enormous forces generated when firing a 95-pound projectile at a muzzle velocity of 2,850 feet per second. The entire system was designed to be broken down and transported by truck, unlike German heavy guns that often required specialized rail cars and permanent emplacements. German heavy artillery, by contrast, emphasized even greater range and shell weight at the cost of mobility and rate of fire. The 170mm Canon 18, Germany's standard heavy gun, fired a 140-pound shell but required a crew of 16 men and could achieve only 2 rounds per minute under ideal conditions. The gun weighed over 39,000 pounds in firing position and was so difficult to move that German units often left them in fixed positions, making them vulnerable to American counter-battery fire once located. The 210mm Mörser 18 was even more cumbersome, weighing nearly 37,000 pounds and requiring a specialized tracked vehicle to move it any meaningful distance. These weapons were devastating when they could be brought to bear, but their lack of mobility meant they were increasingly vulnerable as the war progressed and American artillery became more aggressive in hunting German guns. The Long Tom's design philosophy reflected a fundamental difference between American and German approaches to artillery warfare. German doctrine emphasized the massive, decisive barrage that would overwhelm enemy positions with sheer weight of fire before an infantry or armor assault. Artillery was concentrated, carefully positioned, and used sparingly due to ammunition shortages and the difficulty of repositioning heavy guns. American doctrine, by contrast, emphasized flexibility, responsiveness, and sustained fire. Artillery was meant to be mobile, capable of shifting positions to avoid counter-battery fire, and supplied well enough to maintain fire for hours or even days without pause. The Long Tom embodied this philosophy perfectly, capable of firing 2 rounds per minute for sustained periods, accurate enough to engage point targets at maximum range, and mobile enough to displace and re-emplace within hours. The ammunition for the Long Tom was equally impressive and equally underestimated by German intelligence. The standard M101 high-explosive shell weighed 95 pounds and contained 15 pounds of TNT, or Composition B explosive, creating a lethal radius of 75 feet and a casualty radius extending to 150 feet. The fragmentation pattern from a single Long Tom shell could neutralize an area roughly the size of a football field. For penetrating fortifications, American artillerymen used the M112 armor-piercing shell, which sacrificed explosive content for a hardened steel body capable of punching through 3 feet of reinforced concrete before detonating. Against personnel in the open, the M314 shell with its variable time fuse could be set to airburst, creating a lethal rain of shrapnel that could clear an area the size of 2 basketball courts with a single shot. German troops who survived Long Tom bombardments reported a terror unlike anything they had experienced on the Eastern Front, where Soviet artillery, though numerous, lacked the accuracy and sustained fire of American guns. A German infantryman of the 352nd Volksgrenadier Division, interviewed after his capture during the Battle of the Bulge, and his testimony now preserved in U.S. Army historical records, described the experience. You could hear the shells coming for 3 or 4 seconds before impact, a sound like a freight train falling from the sky. When they hit, the ground erupted, men disappeared, bunkers collapsed, there was no safe place, and they never stopped firing. Hour after hour, the shells kept coming. The accuracy of the Long Tom was particularly shocking to German forces accustomed to artillery that was powerful but imprecise. American forward observers, equipped with radios that German forces could only dream of having in such numbers, could call for fire and have shells landing on target within 5 minutes. The use of aerial observation, impossible for German forces due to Allied air superiority, allowed American artillery to locate and engage targets that would have been invisible to ground observers. The L-4 Grasshopper observation planes, slow and vulnerable but operating in skies dominated by American fighters, circled over German positions with impunity, radioing corrections to Long Tom batteries that adjusted their fire with mechanical precision. The mathematics of Long Tom fire were devastating. A single battalion of 12 guns, firing at a sustained rate of 2 rounds per minute per gun, could deliver 24 shells, nearly a ton of high explosive, onto a target area every 60 seconds. In a 10-minute fire mission, a Long Tom battalion could expend 288 shells, delivering over 13 tons of explosives onto an area roughly 400 meters square. German positions that had been designed to withstand conventional artillery fire, with overhead protection calculated to stop 150mm howitzer shells, proved woefully inadequate against the sustained battering of Long Tom fire missions that could continue for hours. The logistics supporting the Long Tom were equally impressive and equally misunderstood by German intelligence. Each gun required approximately 200 rounds per day during active operations, with each shell weighing 95 pounds and requiring specialized handling and storage. A single Long Tom battalion consumed over 100 tons of ammunition daily, requiring a dedicated supply convoy of trucks just to keep the guns fed. German logistics officers, struggling to deliver even basic supplies to frontline units, couldn't conceive of an enemy that could maintain such consumption rates across dozens of heavy artillery battalions simultaneously. Yet American logistics did precisely that. With ammunition ships arriving in French ports daily, rail lines restored within weeks of capture, and truck convoys running 24 hours a day to ensure that no American artillery unit ever ran short of shells. The deployment of long toms in France, beginning in June 1944, transformed the artillery balance in northwest Europe. German forces that had grown accustomed to Soviet artillery, which was numerous but often poorly supplied and rigidly controlled, discovered that American artillery was a different beast entirely. It was responsive, accurate, seemingly unlimited in ammunition, and capable of reaching targets the Germans believed were safe. German commanders who positioned their headquarters based on the assumption that they were beyond American artillery range found themselves under fire from guns they couldn't see, positioned miles beyond what they believed was the effective range of American weapons. The Battle of Normandy provided the first large-scale demonstration of long tom capabilities against German fortifications. The city of Cherbourg, heavily fortified by the Germans with bunkers, gun emplacements, and underground shelters designed to withstand naval bombardment, was systematically reduced by American artillery, including multiple long tom battalions that fired over 15,000 rounds into the defences during the final assault. German garrison commander, General Lieutenant Karl Wilhelm von Schlieben, later testified that the American artillery bombardment was more devastating than anything he had experienced in 5 years of war. The concrete fortifications that were supposed to protect his forces cracked and collapsed under the sustained pounding of 95-pound shells, arriving from ranges that German engineers had never anticipated when designing the defences. At Saint-Lô, where German forces had established a defensive network of mutually supporting strongpoints, American long toms systematically dismantled the German positions from ranges that kept the guns safe from German counter-battery fire. German artillery attempting to respond found themselves outranged, their positions located by American observation aircraft and subjected to devastating counter-battery fire before they could effectively engage American positions. The imbalance was so severe that German artillery units began limiting their fire to brief, intense bombardments followed by immediate displacement, a tactic that reduced their effectiveness but was necessary for survival against American counter-battery capabilities. The psychological impact of the long tom on German forces was profound and well documented in captured German documents and post-war interviews. German soldiers who had endured the massive but relatively inaccurate Soviet artillery bombardments on the Eastern Front found American artillery to be far more terrifying, despite often being less numerous. The precision, sustained fire, and apparent inexhaustibility of American guns created a sense of helplessness among German troops who realized that no position was truly safe, that bunkers could be destroyed, that headquarters could be targeted, that supply dumps could be obliterated, all from guns positioned so far away that German forces couldn't even locate them, much less engage them effectively. The employment of long toms during Operation Cobra, the American breakout from Normandy in late July 1944, demonstrated the weapon's decisive impact when integrated into combined arms operations. American heavy artillery, including long tom battalions, prepared the assault with a bombardment that pulverized German defensive positions, destroying command posts, severing communications, and neutralizing German artillery before American armor and infantry even began their advance. German forces attempting to organize counterattacks found their assembly areas under fire from long toms, guided by aerial observers. Their columns disrupted before they could even reach the front lines. The German response to American artillery superiority was hampered by declining industrial capacity, fuel shortages, and the loss of experienced crews. By late 1944, German heavy artillery production had slowed to a trickle, with factories prioritizing tanks and aircraft over guns. The heavy guns that remained operational were increasingly immobile due to fuel shortages that prevented their displacement after firing missions, making them sitting targets for American counter-battery fire. German artillery doctrine, which had been developed during an era of German superiority, proved inadequate against an enemy that possessed better guns, better ammunition, better observation, and seemingly unlimited supplies. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Battle of the Ardennes Forest in autumn 1944 provided perhaps the most brutal demonstration of long tom effectiveness against German fortifications. The dense forest, with its steep hills and narrow valleys, seemed ideally suited for German defensive warfare. German engineers had constructed an elaborate network of bunkers, pillboxes, and sheltered positions, many of them built into the hillsides with overhead protection designed to withstand conventional artillery. The Germans believed that the thick forest canopy would prevent effective American artillery observation and that the terrain would limit American ability to maneuver heavy guns into effective firing positions. They were partially correct. The forest did complicate American operations, but what German planners hadn't anticipated was that American long-tom batteries would simply position themselves outside the forest at ranges of 12 to 15 miles and systematically destroy German positions through map-based targeting and aerial observation. American spotter planes, circling above the forest canopy where German anti-aircraft fire couldn't reach them, identified German positions and radioed coordinates to long-tom batteries positioned in cleared areas miles away. The result was devastating. German bunkers that had been carefully positioned to provide interlocking fields of fire found themselves under bombardment from weapons they couldn't see, couldn't reach, and couldn't escape. Oberst Wilhelm Osterhold, commanding the 275th Infantry Division's artillery in the Hurtgen, reported to his superiors in November 1944 that American counter-battery fire was so accurate and so sustained that his guns could fire only a handful of rounds before needing to displace or risk destruction. His report, preserved in German military archives, noted that the Americans possess artillery observation capabilities far exceeding anything we have encountered. They locate our positions within minutes and bring fire to bear from ranges that render our own counter-battery fire ineffective. Our guns are being systematically hunted and destroyed. The technical specifications of the Long Tom told the story of American engineering excellence that German designers had failed to match. The gun's barrel, manufactured from high-grade steel using advanced metallurgical processes developed by American industry, could withstand the enormous pressures generated during firing while maintaining accuracy over thousands of rounds. German heavy gun barrels, by contrast, wore out relatively quickly, with accuracy degrading noticeably after several hundred rounds. The scarcity of high-quality steel in Germany by 1944 meant that replacement barrels were increasingly difficult to obtain, forcing German artillery units to continue using worn-out tubes that scattered their fire wildly. The Long Tom's carriage design incorporated lessons learned from decades of American artillery development. The split-trail configuration provided exceptional stability during firing, while allowing the gun to traverse a full circle when properly emplaced, giving American crews the ability to engage targets in any direction without having to reposition the entire weapon. The equilibrators, using spring mechanisms to balance the barrel's weight, allowed the crew to elevate and depress the gun manually despite its massive weight. German heavy guns typically required more complex mechanisms that were prone to mechanical failure, especially in the harsh conditions of the European winter. The ammunition handling system for the Long Tom, while not automated, was carefully designed to maximize crew efficiency. The shells, stored in specially designed containers that protected them from moisture and shock, could be manhandled by 2 men despite their 95-pound weight. The propellant charges, packaged in brass cases or combustible cloth bags depending on the type, were designed for rapid loading. An experienced crew could maintain a sustained rate of 2 rounds per minute for extended periods, with brief bursts of 3 rounds per minute possible during critical fire missions. German crews operating heavier guns struggled to match even half this rate of fire, putting them at a severe disadvantage in counter-battery duels. The forward observer system that directed Long Tom fire was itself a revolution in artillery employment that German forces never successfully replicated. American forward observers, typically officers or senior NCOs specially trained in artillery procedures, accompanied frontline units with radio equipment that allowed them to call for fire within minutes. The standard procedure involved the observer identifying a target, radiating coordinates, and target description to the fire direction center, receiving a fire mission within 2 to 3 minutes, and then adjusting fire until the target was neutralized. The entire process, from target identification to first rounds on target, typically took 5 to 7 minutes for a proficient battery. German artillery observation, by contrast, relied heavily on wire communications that were frequently cut by artillery fire or Allied air attacks, forcing observers to use runners or motorcycle couriers to transmit fire missions. This meant that German artillery response times were measured in tens of minutes or even hours rather than the minutes required by American batteries. By the time German shells arrived, American units had often already displaced, while German positions remained vulnerable to the accurate and responsive American counter-battery fire. The integration of aerial observation into American artillery doctrine multiplied the effectiveness of weapons like the Long Tom. The L-4 Grasshopper, a military version of the civilian Piper Cub, could remain aloft for hours, its pilot and observer spotting German positions and radioing corrections to artillery batteries. These slow, fragile aircraft operated with near impunity over the battlefield thanks to overwhelming Allied air superiority. German attempts to shoot them down with anti-aircraft fire usually only revealed the position of the German guns, which would then be targeted by Long Tom batteries. One American artillery observer, pilot in the 1st Army sector, claimed to have directed fire missions that destroyed 17 German guns during a single month of operations in November 1944. The impact of Long Tom fire on German logistics was equally devastating. German supply dumps, positioned miles behind the front lines in locations believed to be safe from American artillery, found themselves under accurate fire from Long Tom batteries. Ammunition stores exploded in massive detonations visible for miles. Fuel dumps burned for days, sending columns of black smoke into the sky that served as beacons for further Allied air attacks. German logistics officers, already struggling with fuel shortages and transportation difficulties, found their task nearly impossible when even rear-area depots were vulnerable to American long-range artillery. The destruction of the German 7th Army's main ammunition dump near Prüm in February 1945 illustrated the Long Tom's strategic impact. The dump, containing over 3,000 tons of artillery ammunition, small arms rounds, and explosives, had been positioned nearly 20 kilometers behind the German front lines, well beyond what German planners believed was the range of American guns. On February 9th, American 3rd observation aircraft located the facility and called in fire from a Long Tom battalion. The first ranging rounds bracketed the target. The second salvo hit directly, igniting a chain reaction of explosions that destroyed the entire facility and killed over 200 German personnel. The loss of this ammunition directly contributed to the collapse of German resistance in the Eifel region as artillery units ran critically short of shells. German attempts to develop countermeasures to American artillery superiority were hampered by industrial limitations and the deteriorating war situation. Plans to produce improved heavy guns with better range were abandoned as German factories prioritized tank and aircraft production. Development of better fire control systems and ranging equipment was interrupted by Allied bombing raids that destroyed research facilities and killed experienced engineers. Even basic improvements to existing guns were often impossible to implement due to shortages of critical materials and skilled labor. The few German heavy guns that did match or exceed the Long Tom's range, such as the 240mm Kanone Dre, were so heavy and unwieldy that they required permanent emplacements and rail transportation. These weapons, while impressive in raw power, lacked the tactical flexibility that made the Long Tom so effective. German railway guns, despite their enormous calibers and ranges exceeding 40 kilometers, were effectively mobile targets for Allied aircraft once located. The massive rail-mounted guns required extensive preparation to fire, couldn't be easily relocated, and consumed ammunition at rates that German logistics couldn't sustain. The Battle of the Bulge in December 1944 through January 1945 demonstrated the decisive advantage American artillery, including the Long Tom, provided even when surprised by a massive German offensive. During the initial German assault, fog and snow limited American air operations and temporarily reduced the effectiveness of American artillery observation. German forces, achieving surprise and initial success, believed they had caught American forces off balance and vulnerable. The illusion lasted less than 48 hours. As weather cleared and American forces organized their defense, Long Tom battalions positioned around the shoulders of the German penetration began systematically destroying German artillery, command posts, and supply columns. The town of Saint-Vith, a critical road junction that German forces needed to maintain their offensive momentum, remained contested, largely because American Long Tom batteries, positioned 15 miles away, could interdict German reinforcements and supply convoys attempting to reach the town. German commanders reported that movement during daylight became suicidal once American observation aircraft returned to the skies, guiding Long Tom fire onto any German column that attempted to advance. General Major Siegfried von Waldenburg, commanding the 116th Panzer Division during the Bulge Offensive, later testified that American artillery made it impossible to mass forces for the breakthrough attacks that German plans required. His division's assembly areas came under Long Tom fire, despite being positioned miles behind the front lines. Ammunition trucks exploded before they could unload. Command posts were destroyed, severing communications. When his panzers finally advanced, they found American positions reinforced and ready, having used the time purchased by artillery fire to establish defenses that stopped the German assault cold. The concentration of American artillery fire during critical moments of the Bulge battle was staggering even by the standards of World War II, a conflict that saw artillery employed on unprecedented scales. During the defense of Bastogne, American artillery, including Long Tom battalions positioned outside the encirclement, fired over 150,000 rounds in support of the besieged garrison between December 19th and December 26th. German forces attempting to break through to the town found themselves advancing through a maelstrom of steel, with American forward observers in Bastogne itself directing fire onto German positions with devastating accuracy. The ammunition expenditure during the Bulge would have been impossible for German forces to match. American logistics delivered over 300,000 tons of ammunition to artillery units during December 1944 and January 1945, more than Germany's total artillery ammunition production for the entire period. The contrast between American abundance and German scarcity became even more stark as the battle progressed, and German artillery units, having expended their initial supply of shells during the opening bombardments, found themselves rationing ammunition while American guns continued firing without pause. The crossing of the Rhine River in March 1945 showcased Long Tom capabilities in supporting offensive operations. During Operation Plunder, the British and American assault crossing of the Rhine, Long Tom battalions positioned on the western bank systematically destroyed German positions on the eastern bank from ranges that kept the guns safe from German counter-battery fire. The bombardment, coordinated with air attacks and direct fire from tank destroyers, pulverized German defenses before the first assault boats entered the water. German troops attempting to organize counterattacks found their assembly areas under fire from Long Toms, guided by aerial observers who circled overhead in broad daylight, secure in the knowledge that German anti-aircraft defenses had been largely destroyed, and the Luftwaffe no longer controlled any airspace over the battlefield. General Lieutenant Fritz Bayerlein, commanding the LIII Corps defending the Rhine sector south of Wesel, reported that American artillery fire was so intense and accurate that movement during daylight was impossible, and even nighttime movement was extremely hazardous. His headquarters, positioned 6 kilometers behind the river in a location chosen specifically to be beyond American artillery range, came under Long Tom fire on March 23rd, forcing him to relocate to a commandeered farmhouse basement. The new location was targeted within hours, suggesting to Bayerlein that American observation capabilities exceeded anything German forces could counter. The final campaigns in Germany saw American Long Tom batteries employed in direct support of advancing infantry and armor, their long range allowing them to engage targets far ahead of the front lines. German forces attempting to establish defensive lines found their positions under fire before American ground forces even came into view. Bridges, crossroads, and defiles that German commanders hoped to defend were interdicted by Long Tom fire that made reinforcement and resupply impossible. The pace of the American advance, often exceeding 30 miles per day, was made possible in part by artillery that could reach far enough ahead to disrupt German attempts to organize coherent defenses. The statistics from the final months of the war tell the story of overwhelming American artillery superiority. From January through May 1945, American forces in Europe fired approximately 31 million artillery rounds of all calibers, including over 3 million 155mm shells for long toms and similar heavy guns. German artillery production for the same period was approximately 1/10 that amount, and much of what was produced couldn't be delivered to frontline units due to transportation disruptions caused by Allied air attacks and the general collapse of German logistics. The kill-to-expenditure ratio for long-tom ammunition was remarkably efficient by artillery standards. Post-war analysis of American artillery effectiveness estimated that long-tom fire missions resulted in approximately 1 German casualty or vehicle destroyed for every 12 to 15 shells fired, a rate far superior to smaller caliber artillery and comparable to airstrikes while being available regardless of weather conditions. The ability to deliver precise, sustained fire at ranges exceeding 15 miles meant that long toms could engage German forces throughout their depth, targeting not just frontline positions but headquarters, supply dumps, artillery batteries, and assembly areas far behind the lines. German officers interviewed after the war consistently cited American artillery as one of the most significant factors in their defeat. The combination of accuracy, range, responsiveness, and seemingly unlimited ammunition created a situation where German forces felt constantly vulnerable, unable to mass for counterattacks, unable to protect their rear areas, unable to maintain cohesive defences under the sustained pounding. One panzer officer remarked that, "We feared American artillery more than their tanks or aircraft. The tanks we could fight if we had fuel and ammunition. The aircraft we could hide from when they weren't flying. But the artillery was always there, always accurate, always ready to fire." The long tom's effectiveness wasn't solely due to its technical characteristics, impressive as they were. The weapon succeeded because it was part of an integrated system that included excellent observation, responsive fire direction, reliable communications, and most critically, logistics that ensured ammunition was always available. German heavy guns might match or exceed the long tom in individual capabilities, but they operated within a system that was breaking down by late 1944, with observation hampered by Allied air superiority, communications disrupted by artillery fire, and ammunition scarce due to production shortfalls and transportation difficulties. The training of American artillery crews also contributed significantly to long tom effectiveness. American artillerymen underwent extensive training in survey procedures, fire direction, and gunnery before deploying to Europe. This training emphasized flexibility and initiative, encouraging forward observers to call for fire whenever they identified worthy targets, and empowering battery commanders to engage targets of opportunity. German artillery training, while thorough, emphasized rigid adherence to doctrine and centralized control that proved ill-suited to the fluid warfare of 1944 and 1945. The maintenance and reliability of long-tom guns far exceeded that of comparable German weapons. American guns, built with high-quality materials and designed for ease of maintenance, could fire thousands of rounds with minimal servicing. The barrels, when they did wear out, could be replaced by trained ordnance personnel in the field within a day. German heavy guns required more frequent maintenance, often needed specialized tools and parts that were increasingly unavailable, and suffered mechanical failures that put them out of action for extended periods. By early 1945, German artillery strength was declining not primarily due to combat losses, but because guns were breaking down faster than they could be repaired. The psychological impact of knowing that no position was truly safe from American artillery profoundly affected German morale. Soldiers who could endure direct combat, who could face tanks and infantry in battle, found themselves helpless against artillery fire that arrived without warning from guns they couldn't see or engage. The randomness of artillery casualties, the way a shell could obliterate a squad in their foxhole while leaving adjacent positions untouched, created a sense of fatalism among German troops that sapped their will to resist. Captured German soldiers frequently mentioned American artillery as the reason they had surrendered, describing bombardments that went on for hours with no respite and no possibility of effective response. The employment of long toms in the final assault on German cities demonstrated the weapon's flexibility. During the reduction of Aachen in October 1944, Long Tom batteries positioned outside the city systematically destroyed German strongpoints identified by forward observers. The heavy shells could penetrate the thick walls of buildings that German troops had fortified, collapsing multi-story structures onto their defenders. The siege of Aachen, which German forces had hoped to prolong for weeks, ended in less than 3 weeks, largely due to artillery fire that made holding fortified positions untenable. The contrast between American and German artillery philosophies was perhaps best illustrated by comparing ammunition expenditure. American doctrine held that artillery ammunition should be expended freely whenever worthwhile targets presented themselves. The U.S. Army calculated that it was more efficient to fire 1,000 shells and destroy a target than to conserve ammunition and allow enemy forces to remain operational. German doctrine, shaped by shortages, emphasized ammunition conservation and careful target selection. By 1945, German artillery units were sometimes limited to as few as 5 rounds per gun per day, while American batteries fired hundreds of rounds daily without concern for conservation. The development of specialized ammunition further enhanced Long Tom effectiveness. Proximity-fused shells, incorporating miniature radar units that detonated the shell at optimal height above ground, multiplied the lethality of Long Tom fire against personnel. These shells, introduced in late 1944, created airburst patterns that could clear trenches and foxholes that would have provided protection against ground-burst shells. German troops called them the Devil's Shells, unable to comprehend how American artillery could achieve such precise airbursts. The technology, one of the most closely guarded secrets of the war, remained unknown to German intelligence until American shells with intact fuses were captured and examined, revealing a sophistication in electronics that German engineers couldn't match. The integration of Long Toms with American combined arms doctrine created a synergy that German forces found impossible to counter. When American forces attacked, Long Toms suppressed German artillery during the preparatory bombardment. As infantry and armor advanced, Long Toms shifted fire to German reserves and counterattack forces. When American forces paused, Long Toms interdicted German supply routes and harassed German positions. The flexibility and responsiveness of American artillery meant that German commanders could never achieve surprise and could never mass forces without drawing devastating fire. The crew serving a Long Tom became proficient through constant practice and actual combat experience. The gun commander, typically a sergeant, directed the crew through the complex sequence of preparing the gun for firing, loading, aiming, and firing, while maintaining awareness of the tactical situation. The gunner, using optical sights calibrated for range and deflection, laid the gun on target based on firing data from the Fire Direction Center. The loaders, working in teams, manhandled the heavy shells and propellant charges from storage to the gun, maintaining a rhythm that allowed sustained fire. The ammunition handlers kept shells flowing from the caisson or truck to the gun position. The entire crew worked in orchestrated precision, their efficiency the product of training that German artillery crews, increasingly composed of hastily trained replacements, couldn't match. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.